Hi everyone, my name is Miguel. I'm a Fusion 360 Catalyst, and today I have another fun Fusion video for you guys. I'm going to be showing you how you can leverage the powers of the sweep command to generate some custom threaded features. Not only that, but we're going to go into a bit of basic review about what the sweep command does and what are some of the logic that it follows. So to begin with, I have prepared a couple of basic sketches. This 10mm hexagon, which will be our extrude profile, and these two pathways. One is just a vertical line with an arc, and the other is a spline. And I'm going to be using these in a couple of different ways. So the sweep command is found under the create menu, and what it does in a nutshell is that much like the extrude command, like as you can see here, it generates a 3D body from a 2D sketch along a certain pathway. However, unlike the extrude command, the sweep command isn't simply limited to either horizontal or vertical behavior. By driving the behavior of the feature using a sketch path, as I determined before, I can generate a profile all along the normal vector of this path, as you can see. The extrude actually follows the direction of the line. And using some different orientation, it can actually end perpendicular to the normal vector of the line, the sketch path, or parallel to the original sketch profile. But for now, for the purposes of this video, we're going to leave it at perpendicular. This is useful for generating extremely complicated geometry along a certain direction that you want to follow, like say a toolpath on the surface of a part or a feature that's wrapping around another. And we're going to use this basic principle to generate a thread. However, there are two types of sweeps. One, as you've seen here, is called the single path. There's a more complicated version, requires a third input, called path plus guide rail. What this means is that it will follow the same basic idea as the first. It will bring this extrude profile and generate it along this pathway. However, using the guide rail, as I select here, it stretches the profile and scales it so that it maintains the boundary condition indicated by this third line or guide rail. And I'm just going to make a new body to show you guys. And we're going to take a peek at the cross-section using some sectional analysis. And you'll know, enable that sketch label 2, that as we take a look at the cross-section of this part, it's still fundamentally a hexagon, albeit scaled up, so that the edge of the hexagon touches the guide rail as we show here. This is important because this is one way where we can control the behavior of the sweep, make it twist and turn and grow larger and smaller as we see fit. And that's pretty much all you need to really know about the sweep command to make it work. But one last tip before we get into threads and manipulating this guide rail in 3D is that if you'll notice, if we look at the sketch, the overall length of our guide rail is quite obviously greater than the length of our sketch path. Why is this important? Well, if you look at the sketch feature again, you'll notice that this profile stops at the end of the sketch path and not at the end of the guide rail. Meaning that our new body or extrusion will only go so far as your sketch path intends, and no further than that. The guide rail only exists as a boundary condition under the applicable range given by your initial sketch path. And this can create some logical conditions later on, as you'll see when we try and develop a thread. But that's all you need to know for now. So let's move on. Let me start up a new design here. Okay, so in the next part of this video, I'll be showing you guys how to make a custom thread using the previously covered sweep command. But first, what are some of the ways currently available that we can use to make a thread? Number one is that should you already possess the hole or peg of the right diameter, you can simply use the thread command under the create menu, and make sure to check modeled, to generate the thread of your choice. However, the downside of this is that you are limited to the thread profiles that Fusion has built in. And while numerous, it doesn't contain all possible versions of a thread or all possible thread designs. Another way you can do it is manually creating a coil. By using the coil command and specifying a cylinder of a certain height, pitch, and number of revolutions and so on, it creates thread-like helicals, swept extrusions, like so. And you can modify these with these parameters quite easily. However, the key limitation here is that we are limited to set only a handful of possible cross-sections to make our swept profile: circular, square, and triangular. While useful, this doesn't efficiently approximate any and all threads, especially those of custom geometry. So what do? Well, shortly we will be using the project 3D geometry function of the sketch environment along with the swept environment, along with a sweep from the create environment. We could combine those two to generate a helical extrusion based off of the 3D geometry of this coil and attach it to our own custom profile and then sweep all that to make sure that we have our own custom threaded feature. So let's begin. Again, we're starting out with a raw cylinder, and first we need to use Fusion to generate a coil. Start drawing the coil on the bottom, go all the way up to the top, and we're just going to punch in some parameters here. Let's make it 5 so it looks nice and pretty. That is 50 millimeters. And let's see, our cross section, we want it to be, or my preference is personally triangular external. The reason for this is that when we project the edges of this triangle, they will be wrapping perfectly around the cylinder. And I'm going to make sure it's on the outside and not the inside, because we want those sketch lines. And we're just going to click new body, like so. And another reason why we wanted to do this was because this face right here is already perpendicular to the sketch lines we want to generate. So, for the purposes of a sweep, it already makes so much sense to just do it from there, because it fulfills all the perpendicularity conditions. It will make sweeping our sketch all easier. So, let's start a new sketch right here. Before we do that, let's hide the main cylindrical body, and we're going to use the project or include 3D geometry. Click these two, and the result is that we have 2 helical paths. You have to be thinking, hold on, why do we need 2? Well, the reasons I'm about to show you, we need 1 to be our sketch path and 1 to be our guide rail. Because if we don't, and let's start out by drawing a very primitive custom thread profile here, this weird little oval, and we are going to sweep it along just one of these pathways, like so. I'm going to make a new body too. Oh, change that to single path. And you'll notice, yeah, it completes, but it does this weird twisty thing. And that's odd, because it should be always projecting off of the line, and it is. It actually is. However, it is also, while it is projecting, it is also rotating about the line we specified, because why can't it? There's no boundary condition or constraint to say that it shouldn't. This is what the secondary input is, the guide rail. Now, with our profile and our sketch path selected, all we need to do is select this here, guide rail, hit OK, and mix them up. Path should be different. Guide rail. And there we go. Looking at it from above, and just looking at it right now, it looks so much cleaner than previous. Looking at it from different views, and you'll see that indeed we have successfully managed to create a coiled custom feature. And looking at this, we even got it to extrude the entire way using the distance. And sometimes if this speeds up an error, the two most common errors is that path and guide rail aren't selected properly, and sometimes all you need to do is just swap the two. The other is that even though you have the two guide rails properly selected, it'll refuse to rebuild it. And one quick fix is to change this to like 0.99, just short of 100%. Apparently, this prevents the swept extrusion to fulfill the end conditions of the path where it appears that it's having that difficulty reconstructing. So, handy little tip, and now you know why and what this does based off of the last few minutes of the video. And now that we have this, we can just hide our original sketch. We're a simple Boolean combine, like so. Okay, and there we go. That is our custom threaded feature. Best part is, it's parametric. So we can quite easily, alter the size and dimension of our custom profile. Well, I hope you guys had an enjoyable time watching this video and you're able to pick a couple new tool tips up. Thank you for watching and have a nice day.